The void between galaxies isn't empty. It's not even space as we commonly imagine it. That star, speckled darkness, familiar to telescope gazers. This is something else entirely. A place where the very concept of distance loses meaning, where a single cubic light year might contain nothing more substantial than a few stray atoms drifting like dust motes in a forgotten cathedral. You find yourself floating in this incomprehensible vastness, where the nearest galaxy appears as nothing more than a faint smudge of light, like a street lamp viewed through frosted glass from miles away. The cosmic background radiation, that afterglow of the Big Bang, provides the only constant illumination here, and bathing everything in a uniform glow just 2.7 degrees above absolute zero. It's the universe's most patient light source, slowly red-shifting into nothingness over billions of years. Some astrophysicists still argue whether we should even call this space a void. The term suggests absence, but what exists here is simply different. Dark matter's invisible filaments stretch through the nothingness like cosmic spider silk. Their gravitational influence, the only hint of structure in this apparent emptiness. The temperature isn't uniform either. There are pockets where sparse gas clouds linger at millions of degrees, so diffuse they wouldn't burn your hand if you could touch them, yet hot enough to emit faint X rays detectable across intergalactic distances. A curious thought experiment suggests that if you were magically transported here, without protection, your body would take longer to freeze than to die of decompression. The near-perfect vacuum means heat transfers almost nothing, leaving you to radiate your warmth away over hours rather than seconds. Not that you'd survive long enough to notice. The lack of pressure would do its work first, in a decidedly unpleasant fashion. So, before we drift deeper into this cosmic frontier, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell us where you're listening from tonight, whether it's a bustling city or quiet countryside. We're all sharing this same journey into the void together. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's exploration of the infinite. The scale of this emptiness defies comprehension. If the Milky Way were shrunk to the size of a coffee cup, its nearest galactic neighbor Andromeda would be another cup about 2 feet away. In this scaled-down model, the intergalactic void we're exploring would be the equivalent of nearly a mile of perfect nothingness between each cup. Yet even this nothingness holds secrets. Recent observations suggest there may be more baryonic matter in these voids than previously thought, not enough to collapse into stars or planets, but enough to form an intricate, invisible network of ultra-diffuse gas. Some researchers speculate this could be the missing, normal matter that cosmological models have struggled to account for. Other theories propose more exotic explanations involving quantum field fluctuations or even parallel universes bleeding energy into ours. Meanwhile, the largest structures in the universe, the cosmic web's filaments and nodes, stretch around us like a spider's web viewed from between the strands. We're floating in what cosmologists call a cosmic watershed, the equivalent of the dead zone between river basins where water has no preference which way to flow. Here, gravity's subtle tug of war between galactic clusters creates regions where matter has no clear destination, left to drift for eternity in the intergalactic medium. That faint streak of light passing through the void, it's older than bones, older than dirt, older than the Earth itself. A single photon emitted from a long dead star when the universe was half its current age has been traveling undisturbed for nearly 7 billion years. It slipped between galaxies when the first complex cells were just appearing on our planet, and it will continue its journey long after our sun burns out. This is the loneliest possible existence for a particle of light. In interstellar space, photons might encounter the occasional dust grain or gas molecule. Here in the intergalactic void, the mean free path, the average distance a photon travels before interacting with matter, stretches to about 100 zeros-and light years. That's comparable to the diameter of our entire Milky Way. The photon you're imagining right now has more empty space around it than exists in most people's conception of reality. Some astrophysicists still debate whether these ultra, long-distance photons might carry subtle imprints of their journey. The mainstream view holds that light simply redshifts over cosmic distances, its wavelength stretching as space itself expands. But a controversial 2023 paper suggested that certain quantum properties might be preserved in these pristine photons, that they could theoretically carry uncorrupted information from the early universe if we knew how to read it. The photon's journey isn't perfectly smooth though, even in this near-perfect vacuum. It occasionally encounters the faintest wisps of intergalactic medium, so sparse they make Earth's best laboratory vacuums seem crowded by comparison. About once every few million years, our photon might graze an atom of ionized hydrogen, causing an almost imperceptible deflection. Over cosmic timescales, these microscopic interactions add up, subtly diffusing the light from distant galaxies like headlights in fog, except the fog is so thin it makes the Earth's exosphere look dense. Meanwhile, the expansion of space itself stretches the photon's wavelength, slowly sapping its energy. What began as visible light from some ancient star has long since redshifted into the infrared and will eventually fade into undetectable radio waves. There's poetry in this gradual fading. The universe's equivalent of a whisper, growing quieter with distance, until only silence remains. Your eyes evolved to perceive photons that traveled mere nanoseconds from nearby objects, can't begin to process timescales where light itself becomes archival. That photon you're picturing, it's been traveling since before multicellular life existed on Earth. When it began its journey, our entire galaxy was in a different position relative to its neighbors, moving through space on its own incomprehensibly slow trajectory. So let your breathing sync with these cosmic rhythms. In, out, each breath a tiny counterpoint to light's eternal journey. The void has patience enough for all of it. Your momentary presence here, the photon's billion-year transit, the slow unraveling of the universe itself. The darkness between galaxies isn't truly empty. It's laced with an invisible architecture of dark matter, a cosmic scaffold holding the universe together. Though you can't see or touch it, this mysterious substance exerts its gravitational influence all around you. Its delicate filaments, stretching across the void like strands of a colossal spiderweb. Scientists estimate dark matter outweighs visible matter by about 5-to-1 in these intergalactic regions. Its presence is only revealed through subtle gravitational lensing effects. The way it bends the light from distant galaxies passing through, distorting their shapes like reflections in a funhouse mirror. Some researchers compare it to seeing the outline of an invisible hand pressing against a stretched sheet. The leading theory suggests dark matter consists of DIMPs, weakly interacting massive particles that barely notice ordinary matter exists. But here's the cosmic joke. After decades of searching, we've yet to directly detect a single one. Some physicists still wonder whether we're chasing phantom particles, and whether gravity itself might behave differently at galactic scales. Meanwhile, the dark matter web influences everything around you. That lone photon from earlier, its path has been subtly curved by dark matter's invisible fingers, countless times during its billion-year journey. The sparse hydrogen atoms drifting through the void, they eventually accumulate along these dark matter filaments like dew on a spider's web. Your body, were it unprotected here, would be utterly oblivious to dark matter's constant stream. Trillions of these hypothetical particles might be passing through you every second without a single interaction. The universe's most aloof ghosts. Sleep researchers might call this the ultimate white noise, a background hum of matter that refuses to announce itself. So relax into the unseen embrace of the cosmos' hidden architecture. The dark matter web cradles galaxies apart while keeping them connected, much like the invisible threads of gravity that keep you gently anchored to your bed, even as your mind drifts through the intergalactic void. Beneath the apparent stillness of the void, quantum mechanics is throwing a silent rave. Empty space, even this intergalactic near nothingness, bubbles with virtual particles popping in and out of existence so fast they barely register as statistical noise. This quantum foam, as physicists poetically call it, makes the surface of the most turbulent ocean look placid by comparison. The Heisenberg uncertainty principle permits these microscopic violations of energy conservation. Particle-antiparticle pairs spontaneously emerging, then annihilating each other within fractions of a nanosecond. Normally, this quantum turbulence remains perfectly balanced. But in the extreme gravitational fields near black holes, these virtual particles can become real, producing Hawking radiation. Here in the void, the effect is subtler, just the faintest shimmer in the fabric of space-time itself. Some cosmologists still debate whether quantum foam might explain dark energy's repulsive force. The math suggests these vacuum fluctuations should generate far more energy than we observe, a discrepancy of 120 orders of magnitude, making this arguably the worst theoretical prediction in physics history. Either we're missing something fundamental, or nature has found an elegant cancellation mechanism we haven't discovered yet. Your body, were it floating unprotected here, would be utterly oblivious to this subatomic chaos. Each square nanometer of your skin would experience millions of these quantum fluctuations every second. Virtual electrons, quarks, and neutrinos dancing their brief existence across your surface without leaving a trace. It's the universe's most ephemeral performance, playing to an empty house for eternity. Meanwhile, at scales almost too small to comprehend, space-time itself may have a foamy texture. Some theories suggest that if you could zoom in enough, past atoms, past quarks, past any conceivable measurement, you might find the building blocks of reality resemble a fractal sea of bubbles, constantly rearranging themselves. The void's perfect serenity is thus an illusion, a cosmic magic trick where extreme scales create the appearance of calm. So let your breathing sink with these quantum rhythms, in with the virtual particles, out with their annihilation. The void's apparent emptiness is really just nature's most delicate balancing act, a reminder that nothing is ever truly still, not even between galaxies. The void isn't as lonely as it appears. Billions of rogue planets, dark, frozen worlds ejected from their home systems, drift unseen through the intergalactic night. These orphan worlds travel at speeds that would fling them clean out of the Milky Way. Yet here in the void, they're barely moving relative to the cosmic background. Current estimates suggest there may be 50,000 rogue planets for every star in the universe. Most are ice giants or super-Earths, their surfaces frozen to temperatures near absolute zero. Without a host star, their only heat comes from radioactive decay in their cores, just enough to maintain subsurface oceans on some, locked beneath miles of ice. Some astrobiologists still debate whether these nomadic worlds could harbor extremophile life. The math suggests tidal forces from passing stars or dark matter interactions might provide occasional heating. More speculative theories propose exotic life forms existing in superfluid helium oceans or condensed matter matrices we can scarcely imagine. Your chances of encountering one are vanishingly small. If the Milky Way were shrunk to the size of North America, A rogue planet in the void would be like a single grain of sand drifting somewhere over the Pacific. Yet statistically, one probably passed within a light year of you in the last minute. A dark, frozen world you'll never know existed. These planets carry the stories of their violent births. Some show orbital characteristics suggesting they were flung away during their solar system's chaotic youth. Others might be remnants of failed star formation. Objects that never quite gathered enough mass to ignite fusion. All are now citizens of the void, destined to wander until they evaporate during the universe's heat death, or get captured by another galaxy trillions of years from now. So, when you imagine the void as empty, remember, it's actually filled with more orphaned worlds than all the stars you can see. Each one a dark monument to cosmic chaos, silently sailing through the night. The intergalactic medium holds a secret more delicate than a spider's web. A diffuse mist of hydrogen atoms, so sparse that detecting it requires instruments of impossible sensitivity. On average, just one atom occupies each cubic meter of void space, making Earth's hardest laboratory vacuums seem crowded by comparison. Yet this near nothingness has structure, movement, even weather patterns spanning millions of light years. These lone hydrogen atoms are cosmic survivors. Most were forged in the Big Bang's first minutes, avoiding capture by stars or galaxies for 13.8 billion years. They float in various states, some neutral, others ionized by ancient radiation, bursts long since redshifted into oblivion. Their sparse distribution creates the universe's most perfect insulation. A human-sized volume would contain barely enough atoms to fill a single breath, yet spread across interstellar distances. Some astrophysicists still debate whether this intergalactic medium might contain dark galaxies, invisible structures of gas and dark matter that never formed stars. Theoretically, these could outnumber visible galaxies 10 to 1. Their presence only detectable through subtle gravitational lensing or absorption lines in quasar light. Your body, were it exposed here, would become part of this sparse ecosystem. Over centuries, your molecules would disperse along the void's magnetic field lines, some becoming incorporated into future galaxies, others continuing their lonely journeys indefinitely. The carbon in your cells might eventually find its way to a newborn star system billions of years hence, becoming part of some alien world's atmosphere. Meanwhile, this hydrogen mist plays a crucial cosmic role. It serves as raw material for future galaxy formation, fuel for intergalactic star formation, and a chemical record of the universe's evolution. The atoms you're imagining right now may one day help form civilizations we can't begin to imagine, or they might float undisturbed until the stars themselves burn out. So breathe deep, though there's nothing to inhale. The void's apparent emptiness is really just nature's most patient waiting room, where hydrogen atoms bide their time until the universe needs them again. The void remembers every cosmic collision. Though no sound travels through the intergalactic medium. Gravitational waves from ancient galaxy mergers still ripple through this space like echoes in a cathedral. These distortions in space-time, some dating back to when the universe was half its current age, stretch and compress the very fabric of reality as they pass. When two galaxy clusters collided 1 billion years ago, the event released more energy than all the stars in the visible universe, shining simultaneously for 10,000 years. The resulting gravitational waves now wash over you with imperceptible gentleness, having traveled across cosmic distances. Their peaks and troughs are separated by millions of years, waves so stretched out that an entire human civilization could rise and fall between crests. Some cosmologists still debate whether these ultra-low frequency waves could carry information from other universes. The mathematics of brain cosmology suggests it's theoretically possible, though completely unverifiable. More grounded researchers study how these waves subtly influence the orbits of rogue planets and the distribution of intergalactic gas over cosmological timescales. Your body floating here is being minutely distorted by these waves, expanded and compressed by fractions of an atomic radius. The effect is too small to measure, but real nonetheless. Over millions of years, these waves might theoretically influence the trajectory of individual atoms in the void, though they'd never noticeably affect anything as large as a dust mote. Meanwhile, the waves continue their endless journey. Having passed through you, they'll go on to ripple through other galaxies, through other voids, until the universe's expansion redshifts them into undetectability. They're the closest thing the cosmos has to a memory, an imprint of violence that outlasts its source by eons. So let your breathing sync with these ancient rhythms. The void isn't silent. It's vibrating with stories too slow for human perception, written in space-time itself. The void has weather, not in any recognizable terrestrial sense. No clouds or rain, but in vast, slow, motion systems of million-degree plasma that circulate between galaxies like lazy hurricanes. These ionized gases form the intergalactic medium's atmosphere, with pressure fronts spanning millions of light years and wind speeds approaching 500 kilometers per second. What passes for a storm here would be invisible to human eyes. A galactic merger 100 million years ago might have ejected a bubble of superheated gas, now expanding through the void. Its leading edge a shockwave of charged particles, its interior turbulent with plasma eddies large enough to swallow solar systems whole. Yet this maelstrom is so diffuse that a spaceship could fly through it without noticing, the particles too sparse to trigger radiation alarms. Some astrophysicists still debate whether these plasma currents could explain certain large-scale structures in the cosmic web. The mainstream view attributes these formations to dark matter's gravitational influence, but a provocative minority suggests intergalactic weather patterns might play a secondary role, like ocean currents shaping coastlines over geological time. Your body, were it exposed here, would experience this weather as an impossibly gentle breeze. Perhaps one charged particle every few hours glancing off your skin. The plasma's incredible temperature means nothing when its density is 1,000,000 times thinner than Earth's best laboratory vacuums. It's the ultimate paradox: gases hot enough to vaporize steel, yet so sparse they couldn't warm a snowflake. Meanwhile, these plasma rivers carry heavy elements from ancient supernovae across intergalactic distances. That iron in your blood, its atoms might have traveled such currents before being incorporated into our solar nebula. The void isn't just empty space, it's the universe's circulatory system, distributing the products of stellar alchemy over cosmic timescales. So imagine yourself floating in this slowest of weather systems. The intergalactic winds that shaped our existence are still blowing, still carrying the seeds of future worlds across the darkness. The void remembers. Etched into the fabric of space itself are faint magnetic fields, relics of the universe's infancy, stretched to inconceivable scales by cosmic expansion. These fields are so weak they couldn't deflect a child's compass needle, yet they span intergalactic distances like invisible spiderwebs, preserving a record of primordial chaos. These fields originated in the first picoseconds after the Big Bang, when the universe was smaller than a grapefruit and seething with plasma turbulence. Quantum fluctuations became frozen into the young cosmos like wrinkles in a sheet, then amplified to cosmic proportions as space expanded. Today, they serve as the universe's oldest surviving structures, predating even the first stars. Some cosmologists still debate whether these fields could explain dark matter's distribution. The mathematics suggests magnetic fields might have guided early matter clumping, like iron filings aligning along a magnet's invisible lines. Others propose even wilder ideas, that these fields are shadows from a previous universe, or evidence of higher dimensions imprinting on our own. Your body, floating here, is utterly oblivious to these fields. Their strength measures in femtogos, billions of times weaker than Earth's magnetic field. Yet they subtly influence everything: the orientation of interstellar dust, the acceleration of cosmic rays, even the formation of gas filaments that may one day birth new galaxies. They're the universe's faintest whisper, still telling stories from the dawn of time. Meanwhile, these fields continue evolving at a glacial pace. Galactic winds and intergalactic plasma currents slowly twist and fold them over billions of years. A magnetic origami project on cosmic scales. Some regions may eventually develop knots where field lines tangle into complex configurations, potentially creating portals for energy transfer between galaxies. So let your mind drift along these ancient magnetic contours. The void isn't featureless. It's inscribed with signatures from creation itself, written in a language of invisible forces we're only beginning to decipher. The void glows with ghosts, not the supernatural kind, but the ancient light of stars that died before Earth formed. Photons that have traveled uninterrupted for billions of years through the cosmic wilderness. This extragalactic background light is so faint it makes moonlight seem dazzling by comparison. A uniform glow just barely detectable by our most sensitive instruments. Every cubic centimeter of the void contains about 400 of these primordial photons, relics from when the universe was 10% its current age. They outnumber atoms in intergalactic space by a factor of 1 billion, creating a sea of light so diffuse it would take a collector the size of Jupiter, gathering for centuries, to capture enough energy to power a single light bulb for a second. Some astrophysicists still debate whether this background light could encode information from the early universe. The photons have been redshifted so severely they now sit in the microwave and radio bands. Their original visible colors stretched beyond recognition, yet theoretically, subtle anisotropies in their distribution might reveal details about cosmic structures that no longer exist. Your eyes, adapted to Earth's generous light levels, would perceive nothing but perfect darkness here. Even with pupils fully dilated, not enough photons would arrive each second to trigger a neural signal. It's the ultimate paradox, floating in a sea of light so thin it registers as blackness. Meanwhile, this light continues its endless journey. The photons passing through you right now will go on to traverse other voids, other galaxies, until the universe's expansion stretches them into complete undetectability. Some may eventually be the last light left in existence, quietly persisting long after the final stars burn out. So close your eyes and imagine these gentle photons, each one a messenger from the cosmic dawn, still traveling though its source vanished eons ago. The void isn't dark, it's filled with the afterglow of creation itself. The void is flowing across unimaginable distances. Entire galaxy clusters drift towards some unseen attractor with stately inevitability. Astronomers call this phenomenon dark flow, a mysterious large-scale motion that defies conventional models of cosmic expansion. Like leaves caught in a slow river current, thousands of galaxies move in concert towards something beyond the observable horizon. This motion was discovered by tracking thousands of galaxy clusters through the cosmic microwave background. Their collective velocity, nearly 1,000 kilometers per second, suggests gravitational influence from structures so distant their light hasn't had time to reach us in the universe's 13.8 billion year history. The scale boggles the mind. We're talking about mass concentrations, potentially hundreds of times larger than the Great Attractor. Their gravity warping space-time across billions of light years. Some cosmologists still debate whether dark flow might be evidence of a pre-Big Bang universe tugging at our cosmic bubble. The mathematics of conformal cyclic cosmology allows for such scenarios, though they remain firmly in speculative territory. More conservative theorists propose these flows could simply be residual motion from the universe's inflationary period like ripples frozen in an expanding pond. Your position in the void is caught up in this grand motion. Right now, you're moving toward the constellation Centaurus at about 370 kilometers per second relative to the cosmic microwave background, a speed that would get you from Earth to the Moon in 16 minutes, yet feels like perfect stillness in the cosmic context over millions of years. This drift will carry you and everything in our local universe towards something we can't yet see. Meanwhile, the mystery deepens with every new observation. Recent surveys suggest dark flow might extend even farther than initially measured, potentially challenging our understanding of cosmic isotropy. Whatever lies beyond our observable horizon, it's massive enough to gently steer galaxies like a hand guiding paper boats across a pond. So surrender to the cosmic current. The void isn't static. It's carrying us all towards some distant revelation at a pace too slow for human perception, but inevitable as gravity itself. The void breathes. Across intergalactic distances, galaxies exchange matter in a slow, rhythmic transfer astronomers poetically call intergalactic rain. This isn't water, of course, but ionized gas stripped from galaxies by tidal forces and ram pressure, now condensing back onto other galaxies along invisible filaments. The process takes billions of years, less like rain and more like watching a stalactite grow. Our Milky Way currently floats in a relatively dry region of the cosmic web, but evidence suggests it too experienced these showers in the distant past. Some of the gas in your body might have arrived via such intergalactic precipitation, having been ejected from a neighboring galaxy during some ancient collision, before eventually finding its way into our solar nebula. Some astrophysicists still debate whether this process could explain certain galactic metallicity anomalies. The chemical fingerprints of intergalactic rain differ subtly from gas that's always remained within galaxies, potentially offering clues about our cosmic neighborhood's violent history. More speculative theories suggest some high-velocity clouds might actually be splashback from our galaxy's passage through the local sheet. Your position in the void offers a unique perspective on this process, looking through the cosmic watershed. You might see faint streams of gas flowing along dark matter filaments, the intergalactic equivalent of watching rain fall in extreme slow motion. A single droplet's journey from one galaxy to another could take longer than the entire history of multicellular life on Earth. Meanwhile, new simulations reveal unexpected complexity in these flows. What appears as smooth accretion at large scales actually consists of countless discrete filaments, winding around each other like braided rivers. The gas cools as it falls, sometimes forming molecular clouds before reaching its destination, islands of temporary structure in the intergalactic void. So imagine yourself floating in this gentle cosmic precipitation. The void isn't just taking, it's giving back, redistributing matter in a cycle measured in galactic lifetimes. Every atom is just visiting, temporarily incorporated into stars and planets, before eventually returning to the intergalactic medium in an endless, stately dance. The void contains holes, not mere empty space, but proper absences, regions where the expected galaxies simply don't exist. The largest known is the quietest void, a spherical region 330 million light years across, containing only about 60 galaxies, where there should be thousands. From within, the night sky would appear nearly black, with just a few faint smudges breaking the perfect darkness. These cosmic voids aren't accidents, but fundamental features of the universe's large-scale structure. They form where multiple bubble, like expansions in the early universe, intersected, creating regions of negative curvature that repelled matter during cosmic dawn. The quietest void in particular may be a void of voids, where several smaller empty regions merged over billions of years. Some cosmologists still debate whether these voids could contain concentrated dark energy or other exotic physics. Their extreme underdensity makes them natural laboratories for testing gravitational theories. Einstein's equations predict subtle differences in how space expands inside versus outside voids. A controversial 2024 paper even suggested certain void properties might hint at higher dimensions. Your location in the void gives perspective on these absences. The average cosmic void measures about 100 million light years across, meaning if our Milky Way occupied typical void space, we'd see only about 1,000 galaxies in our sky instead of the roughly 100 billion visible from Earth's suburbs. The cosmic web's filaments would appear as distant, tenuous walls surrounding an unimaginable emptiness. Meanwhile, voids continue evolving in slow motion. As the universe expands, they grow at the expense of surrounding filaments, not by expanding outward, but by becoming even emptier as galaxies drift toward denser regions. Over trillion-year timescales, voids may merge into ever larger absences until the cosmic web resembles Swiss cheese on galactic cluster scales. So contemplate this perfect nothingness. The void isn't uniform. It has architecture, with absences as carefully shaped as presences. These cosmic holes are just as important to the universe's structure as the glittering galaxies. Negative space defining the positive in the grandest artistic composition imaginable. The void hums, not with sound. That's impossible in near perfect vacuum, but with the cosmic microwave background's uniform glow. The afterimage of the Big Bang stretched into microwaves by 13.8 billion years of cosmic expansion. This radiation bathes every cubic centimeter of the universe, including the space between galaxies, with about 400 photons per cubic centimeter, all redshifted to just 2.7 degrees above absolute zero. This background isn't perfectly smooth. Tiny fluctuations in temperature, about 1 part in 100,000, reveal density variations in the early universe that eventually grew into galaxies and clusters. Seen from the void's perspective, these anisotropies form a complex pattern that encodes the universe's entire large-scale structure in embryonic form. The cosmic web you see today was writ small in those first microseconds. Some cosmologists still debate whether deeper analysis of this background could reveal pre-Big Bang physics. Certain inflationary models predict specific patterns that might be detectable with next-generation telescopes, potentially offering glimpses beyond our cosmic horizon. Others suggest the CMB might contain evidence of bubble universes colliding with ours in the distant past. Your body, floating here, is being gently warmed by this radiation, about 0.001 watts in total, barely enough to register against your suit's insulation. Yet this feeble glow is literally the oldest thing you'll ever experience. Photons released when the universe was just 380,000 years old, now reaching you after an uninterrupted journey across intergalactic space. Meanwhile, the background continues redshifting as the universe expands. In about 1 trillion years, it will have faded to undetectability, leaving future civilizations in a far more isolated cosmos, with no visible evidence of the Big Bang at all. We live in a privileged era when the universe's birth announcement is still faintly audible. So tune your awareness to this ancient whisper. The void isn't silent. It's filled with the fading echo of creation itself, a lullaby 13.8 billion years in the making. The void has edges, not in the sense of boundaries, but as transitional zones where emptiness yields to structure. These frontiers are fractal in nature. Zoom in on what appears to be the void's border, and you'll find smaller voids within filaments, within superclusters, all the way down to the scale of individual galaxy groups. The universe is emptiness all the way down. At these interfaces, strange physics emerges. Gas filaments too diffuse to form stars nonetheless accumulate along dark matter's unseen scaffolding, creating the universe's largest recognizable structures. Some span hundreds of millions of light years, while being only a few million light years thick. Cosmic walls, so vast their curvature appears flat from any vantage point within them. Some cosmologists still debate whether these transition zones could host exotic forms of matter. The extreme density contrasts might theoretically permit strange quantum phenomena or non-equilibrium chemistry we've never observed. Others suggest these regions might be where dark matter interacts most strongly with normal matter, if such interactions exist at all. Your position in the void offers a unique perspective on this cosmic shoreline. Looking inland, you see the void's perfect emptiness stretching toward infinity. Looking seaward, the faint glow of distant galaxy clusters forms a hazy horizon, not unlike an ocean viewed from high altitude, where individual waves blur into a uniform shimmer. Meanwhile, these boundaries continue shifting at cosmological speeds. As the universe expands, the void grows while filaments thin, a slow motion invasion of nothingness that will ultimately leave most galaxies isolated in ever larger empty spaces. The cosmic web isn't static, but an evolving tapestry where emptiness and structure dance to gravity's slow tune. So let your awareness hover at this frontier, The void's edge isn't an ending, but a transition, one of countless nested borders in a fractal universe, where emptiness and matter endlessly redefine each other across scales no single observer could ever fully encompass. And so the void cradles you, not empty, but full in its own quiet way. The dark matter's unseen threads, the quantum foam's endless fizz, the slow dance of rogue planets, and the whisper of ancient light all continue their stately motions, indifferent to human scales of time and attention. The cosmic microwave background's gentle glow, now red-shifted to near nothingness, still carries the imprint of creation's first light. Those photons that have travelled longest through the void now pass through you as well, their journey continuing long after your awareness of them fades. The dark flow's current, mysterious as it is, carries everything in its path towards some distant revelation you'll never witness. Let the vastness soothe you. The questions still unanswered, the mysteries still unresolved. They'll keep for another day, another aeon. The void has waited 13.8 billion years for your momentary attention. It can wait a little longer. Your breathing slows. The cosmic web's filaments blur into soft focus. The boundary between self and space grows porous as the void's rhythms become your own. There's no need to hold on, no need to understand. However briefly, you've floated at the universe's quiet heart.